the central position of a frequency distribution for a group of data. Or we can say measures of central tendency are statistical tools that describe the central position of a set of data. So, my grade our students are mathematics. 100 that example is an example of a state of data, isn't it? So, measures of central tendency, as the name shows or tells us, they are interested in showing you the central location of that state of data. Because you use that center in order to describe, to rate, to label, or to have meaning of your data. So they will always show you that all this data, the center is this. And that center, you can use it to understand the meaning of that particular data. So we are trying to explain here, to explain that when we talk about frequency distribution, we are looking at the distribution and also the pattern of the data that we have collected. In our case, we are talking about data of the scores of mathematics. So in most cases, in order for you to have a very good understanding of that data, you need to order it so that there is a pattern showing. So common sense tells us that you begin from smallest to highest, so lowest to highest. So when you have data, usually that's it. You recognize it. Now, examples of the tools which are forward measures of central tendency are three. We've got the three examples. We've got the mode, we've got the median, and we've got the mean. These three tools, all of them, they describe the central position of the set of data in their own way. Yes. Exactly. So in primary we just introduced as basics, but here you know they are used as why. Okay. So you have mean, median, and mode. These are tools which are called measures of central tendency, because all of them they point you to say this is the center, this is the average of the set of data that we have collected, and the meaning of this data because of the average which they are giving you is extraordinary. So you are able to interpret the data. So let's look at these three. Look at the function of the mean, median, and mode, and the differences. And why are they different? Okay. Right. So let's start with the mean. So the mean is sometimes known as the common average. It is usually referred to as a common average, which summarizes the set of data to indicate the central position of That one is not touched. It's called the common average, and it summarizes your set of data. Summarizes your set of data to indicate the central position of your data. In addition to that, the mean also always assumes that the distribution is normal. Those are the characteristics of the mean. It assumes that the distribution is normal. And can only be used with interval and ratio data. Can only be used on interval or ratio data. It means you cannot use mean for nominal and ordinal data. You remember the types of data. Not use for them. Why? Just because those two types of data come in form of words. Not necessarily. If they are numbers, those numbers are not based on mathematical calculations. The ordinal is used to rank, just to show this is number 1, this is number 2, this is number 3, in order for you not to get lost, just to see the order, nominal data. Ordinal data is just names, name of the person, name of the location. So you cannot say, let me see the central position of the name of the location. It doesn't work. So for nominal and ordinal data, you don't use mean. But for interval and ratio data, you know that those are typical numbers. So you can only use it. Yes. If they find average, problem, find mean. But it's not only mean, what's the average? They put more, they put median, or close to more. Understanding what you mean. Okay, I will get that. Sure. So, the last thing that we should note is that we don't use mean to compute average when you have outliers or when you have extreme scores in your set of data set. We do not use mean, or we are discouraged to use mean when we are having extreme scores, which are known as outliers. In your data, if you have outliers in your data set, we don't use mean. you are discouraged using when you have extreme scores. Extreme scores. Then, point number 2, bullet number 200. Number 3, right? About it do not use means there are presence in extreme scores. Extreme scores means outliers. Data which is not similar to the rest of the data. Example, I'll give an example. You see those numbers 3, 5, 6, 4, 5. If you look at 5, 6, and the 3, those ones are similar, those are close to each other. But 4 is away. So that one is an extreme score. It's an extreme data. So you don't use the mean. Why? Let me show you what I'm trying to say. Show you what I'm trying to say. So here we've got 3, 5, 6, 4, and 5. Which is the one? Divided by how many are there? How many? 5, right? We divide by 5. It means mean is 16. So you might imagine that those numbers, that data set represents age of learners in the class. Okay. So one learner is 3 years, the other one is 5, the other one is 6, the other one is 4, the other one is 5. Okay. Now, if you have this mean, so in order for us to come up with mean, it means we add 3 plus 5 plus 6 plus 4 plus 5. The way I did it. We get the 1, then the 1 divided by the number of letters, which is 5. So we get the mean, which is 6.2. So 6.2 means the average age of the learner in this class. So when we look at 6.2 as an average age of the children in the class, what we get, what we have in our mind is that children in this class, they are qualified to start standard 1. You get the idea. We make a general decision based on the need, the average. But is it true that the majority, or that this class is mature, ready to start standard 1? The answer is no. Why? Because only one who is 12 years is even more than 30. But the majority are not yet age 6. So the information has been distorted just because we have got one person who is dictating the information. That one is an extreme score. So if we are to rely on the mean to make a decision, we'll make a wrong decision, we'll make a wrong conclusion. You get it? Just because there is one data which is peculiar, which is extreme, doesn't reflect the truth. However, assuming we were told with another form for it, then one day compute mean. The scenario is different. Don't you can 3, then you add what? 5, then you add 6, then we add 4, we add 4, then 5. 5, which gives us 23. 23 divided by number of letters, which is 5, then our mean is going to be 4.6. So to the nearest whole number is fine. Okay? So it tells us that on average the students in this class are 5 years old. And then we can make a decision based on that one and say the children are not ready. We should still maintain them in the reception class and we prepare them for primary school next year. And here we can be positive just because there are no outliers in that state of data, of age. There are no extreme data, no extreme scores. So that's why we are saying, if you have your data, in terms of similarity, is this data set similar? In further statistics, we call it normal distribution. And the normal distribution, it takes the form of a bell-shaped distribution. Anyway, I want to show you something. Don't have that. Let me just take it here. Let me go to mode. The next one is median. Let's start with median. Median. So median is a score found at the exact middle of a set of data or values. A set of data or values. It's simple. It's simple because if you have your scores, for example, here another data set, 15, 20, 21, 20, 26, 15, 25, 15. You see that? That one is another set of data, and that one is scores of students out of 40 for an English exam. So how many students took the exam in that class? 8. You just counted, isn't it? So 8 students sat for the English exam, and the first one got 15, the second one got 20, the third one got 21, so on and so forth, up to 50. So median is simply a score or a value that is found at the middle, at the center. And that one you will treat it as an average. So you do it manually. You just count 8. What is the center of 8 or half of 8? 4. So let's count and then we identify the score which is at the middle. We have 2. Yes? Just because 8 is an even number. It doesn't have a digit in the middle. So what we'll do for us to be precise, we need to arrange the list. We need to arrange the set of data set from smallest to largest.